from this graph. Now, did we get any yesterday? Did we actually pull any of these, or we just do it conversationally? Just conversationally? Let's get back and let's firm it up a little bit. Mean, median, or mode? Which one do you guys want to attack first? Mode. Here, vote for mode. It's Cassidy. Cassidy with a D, yes. Good. So how are we going to find the mode when data is grouped like this?
The two that are somewhat the same.
Say that again.
The two that are the same. The 0 to 2 and the 3 to 5.
Why are they the modes? Remind me.
Because they're exactly the same.
Well, that's not why they're the mode, though.
They curve them.
Because if there was, for example, I'm going to make up some fictitious data. If we had some folks that had a lot of keys and there were 2 more bars, there would be now 3 that are exactly the same. But we wouldn't call those the mode. How come? What is the mode?
The frequency that they occur.
That the key is in how frequently the data occurs. The reason these are modes in the raw data is because this occurred 4 times, that occurred 4 times, that occurred 4 times, that occurred 4 times, and that occurred 4 times. Freakishly flukish, and I loved it. But if we had one more person that had 2 keys that day, there would be 1 mode and 1 mode only, and the mode would be 2. So the key is, the point is, there we go. The point is, you want to see frequency. How often does something occur? So, Linda, you're right in that these bars represent the modes. But they're the modes because the bars are?
Tallest.
The tallest, which means they're the most frequently occurring. So, here's a condition, though. Good. Monica's like, wait a minute, though. Something's not quite right. Go ahead.
Because it doesn't make sense because there's so many numbers in each.
That's the problem. Ha! That's the problem. Because we know that there are 10 occurrences between 0 and 2. And we know that there are 10 occurrences between 3 and 5. And that's great. But the problem is, what is it? Is it 0? Is it 1? Is it 2? What do we call these in here? So that's a challenge, isn't it? How do we solve that challenge?
Divide it.
How?
Would we find the average?
I think we're going for mode now, yeah? Oh, the average of what, though? What are you getting at?
Of 0 to 2.
And what is that? It's 1, isn't it?
Yeah.
So, what Veronica's got an idea here, make every key in this bar, not 0 or 1 or 2, but call them all 1. Why would that be legit? Why?
Is she finding the median? So
She is finding the median.
essentially 0 and 2 are the extremes in this case.
I like that very much. But I want to adjust it a smidge, just a smidge, Jolene. Instead of throwing out the 0 and the 2, I'm taking each 0 that occurs with each 2 that occurs, and I'm saying these 2 together as 2 units both contribute 1.
Right.
On average. The 0 doesn't, the 2 contributes twice too much, so paired off, they each contribute 1. Now this makes an assumption that might or might not be true. What assumption is, this is a very tricky question, by the way. What assumption does that make? I'm saying for every 0, I want to take a 2, that pair off, and they cancel and make 2 1s instead. Vivica, right?
Yeah.
Go!
That there's the same numbers
Ah!
as 2.
I'm making the assumption that there is the same number of 0s as 2s. Is that a fair assumption? No. That might not be, but hold that concern. I'm thinking for maybe 5 minutes. Hold that concern for maybe 5 minutes. I'm going to come back to it. That's a great concern. We're going to say that too? Carly, yeah. Great concern, both of you guys and anybody else thinking that. But there is something called the law of large numbers that takes care of us, which we'll get to momentarily, I promise you that. So right now, I like this idea. I like Veronica, knock out the 0 and 2 and call it a 1. Knock out the 3 to 5 and call it a 4. Knock out the 6 to 8. Yes. So the same logic occurs, and now you can see right now it's going to fall apart. Knock out the 9 to 11 and call it a 10. There's only one data point in there, yeah? So if it's not a 10, by putting a 10 here, we're either under or estimating that bar, correct? If that was a 9, we are now thinking it's too big. If it was an 11, we're now thinking it's too small. So we're going to be off. If that's not a 10, we're going to be off. It's actually most likely that we are off. But if we're off there, say we're too high there, in your mind, what's probably going to happen somewhere else in one of the bars?
It'll be low.
Alan, yes?
It'll be low.
It's going to be low somewhere else. Now that might take some of you like, wait a minute, my stomach's starting to feel weird. This isn't math, but it still seems kind of tricky. Don't worry. Don't worry. There's a law, not a theory, but a law, a behavioral law, that we're about to see via simulation. I think will make you feel better. It has to do with what you guys were about back there as well. 12 to 14? All right. Beautiful. Now those are not frequencies, right? Those are data points. So now there are 10 ones, there are 10 fours, 7 sevens, 1 10, and 2 13s. That's our new data set. That's our new data set compared to our original raw data. Now this is not as precise, is it? It's not as precise at all. As a matter of fact, what are our new modes? Our new modes are 1 and 4, right? Our new modes from the grouped data are only 1 and 4, which means we lost the 8 and the 5 and the 2. Well, that's okay. I mean, it's okay to lose the 8 and the 5 and the 2. That's going to happen at some time with group data. The 8, there are still 4 8s in this bar, right? It's just that we've now called them all 7s. And there aren't enough 7s to rally this. That's a sacrifice. The mode generally gets hit the hardest with this. The nice thing is, the mode doesn't get used very often except for qualitative data, which I'll come back to, which won't apply in this case. So I don't really care so much about the mode. I'm okay with that. Which was mine next? Where are we messing around with the... Excuse me. I drank a lot of water in the pool yesterday. I think I bleached my trachea. I'm getting better at butterfly. And that doesn't mean I'm good. It just means I'm getting better. I'm drinking a lot of pool. Same problem I had 105 last term with you guys.
Yeah, you did.
We were messing around with the median, weren't we? Last time, I think. Good. Where's the median? 7. Why is it 7?
It's in the middle.
Define middle.
It's between, so there's 5 points that we have.
Oh, 5 bars.
5 bars.
Good. 5 bars, yes.
So you take out the even amount and you're left with the...
Okay. Now you said 2 different things there, Nick, and I love both of them. Nick said there's 5 bars. 5 bars. So you take the same amount of bars off of each side, or the same amount off of each side. So I throw the 2 left bars off and 2 right bars off, and whatever's left in the middle is 7. Careful. I like the logic, just not the delivery. The logic is perfect. You have to take the same number of data off, yes? But that means you have to take the same number of data off. If you throw this bar away and cancel it with this bar, it doesn't cancel. Because there's 10 points in this one and only 2 in that one, yeah?
Right.
So let's cancel. Puberty. Let's cancel. Let's throw off the 2 largest data points. Okay, 1, 2, they're gone now. I've chopped those off. And let's take 2 off of this bar. Maybe it's too small. I'll put it at the bottom, but it doesn't matter. Okay, now that bar has been canceled properly with this one. They're gone now, yeah? Is that fair?
Yeah.
Good. How about that next bar? How many is in that next bar? Just the 1, yeah? He's gone, or she, it's gone. 1 more over here, it's gone. All right? What should we do next?
Cancel the...
I think we start whittling away at that middle bar, right? Because he's got how many in him? He's got 7 in him, yeah? I'm going to go ahead and cancel all 7 of those. 1, 2, 3, 4, 5, 6, 7. And that's going to take care of the rest of this bar, isn't it? We've already canceled 3. It's 10 tall, which means there's 7 more in it. So 1, 2, 3, 4, 5, 6, 7. Now we've canceled 10 off of that side and 10 off of this side. The other 10, so I must have a data set of 30, I'm assuming. The other 10 must be right in here. And now we can keep chopping if you want to, but I don't think there's a need to chop anymore, is there? Because if we keep chopping, we're going to be in the same bar, which is going to put us at a median of 4. Look at that. That's nice, huh? That's nice. Thank you for saying the thing about the bars before, Nick. It drives home the point of a median and why you need to weight it with the frequencies. In other words, tying it back to Monica's point about the median from before. Cool? Good. Those knuckles?
No.
Oh, okay. Good. All right, got the median, we got the mode, 1 thing left, and it's the average. And this is one of my favorites, because this, the tool you're about to learn, if you don't already know it,